Hi, my name is Dan Kelly. I'm a physical oceanographer at Dalhousie University, and I'm thinking a little bit about doing QC, quality control analysis with Argo float data. And so this is just a little video for some colleagues to toss some ideas back and forth. So the basic idea is that it's Argo float QC, that's quality control. It's never clear to me whether that's quality control or is it a QA quality analysis. I don't really know. And in fact, what I'm doing here could just as well be CTD, quality control or quality analysis. If you don't know what CTD and Argo are, you might want to stop watching right now. And I'm going to do this in SQL, but in my plan is to do it in R. But part of the reason why I'm doing it in SQL is that I could do it in SQL, Python, or whatever else, you may have. Okay, so we've already got like about 6 different titles there. And what I'll be doing is explaining a little bit about some database tables that I'll create, and I guess why I'll create them. And I'm going to have a table called floats. To be honest, it's more than quality analysis. Maybe I'm going to say tagging. Yeah, so I'm going to have a database called floats, and it'll have some sort of an ID for the float. So maybe I'll call that ID float. And this will be auto incremented. So that will be just, a counter. You won't set that. And then I'll have something maybe called capital ID for the float and something called maybe cycle for the float. Obviously, if it was a CTD, it wouldn't be called that. Okay, so that's fine. And then I'll maybe make something called tags, and it will have an ID for the tag. And again, that'll be auto-generated. And then it will have some key value, which I guess would be an integer, and some text. Okay, so the text could be things like good and bad, and the ID could be 1 and 2 and things like that. And then I'll have a connection table. And again, that will have a floats tags, an ID for that, the same sort of idea. And then I'll have an ID for the float. Sorry, ID float maybe, an ID tag maybe, and oh, and maybe level would make sense. So the level within the profile. And this would be a connector thing. So for example, if float with the ID number 1 had a tag at levels 5, 6, and 7, and those tags were 1, 2, and 3, then that's what would be contained in this. It would say that float and so forth. So if you don't know, within Argo float, there's an ID for the instrument. The thing goes up and down about every 10 days, every one of those. And on the upcast, it makes a measurement, which is called a cycle. That could actually contain multiple profiles, which I'm not getting into here. All right, so that's the basic idea. And I'm just going to switch my screen now, and I'm going to show you, I'm going to share. Right, so there we are. We're in a Vim editor. Sorry, I'm just resizing things. You can't tell that what I'm doing, but that's why I'm pausing there for a second. Okay, so this is a Vim editor, and the way this works is that the highlighted line is line number 6, and this is a line above and below. So these are not line numbers, they're relative line numbers. Just so I went to the bottom of the file, there's 95 lines. So that gives you a scale for the amount of stuff I'm going to show you here. I'm going to do it briefly. So we're in the R language here. I'm going to use a library called DBI, database interactor, I don't really know. I'm setting the warn option to 3. So if there's any kind of a warning, it will make an error. Setting a little debug flag, and I made a function called MSG for printing stuff out. This doesn't really matter for this, but I do it for all work that I do, so I can have debugging messages as I'm working. I'm going to make a database file called argo.db. I'm going to do this with SQLite. That's how I'm going to do it. SQLite 3. Okay, so in R here, I'm defining a tag scheme. So I'm going to, and normally in oceanography, tags are numerical values, also called flags, actually. It should be called flag scheme, actually. Yeah, and so I'm just making one up here. So one means it's not been assessed yet. Two means that the location of the profile or cycle is known to be bad. Three would mean that at a certain level, see I've said applies to a pressure level. At a certain level, the salinity is bad. That's a measure of salt. I could say the same for temperature. There's many different things. If you're an oceanographer, you know what I mean by an inversion, which is a particular problem with oceanographic data. It's a signal that the data are probably bad. Usually the salinity are bad, by the way. Okay, now I'm revealing why I really care. Other people can worry about QC. I'm not worried about QC myself. But this video is for people who I guess are more worried about QC. I'm interested in finding intrusions. So I'm making up a scheme in R to look through data interactively and have people click on some graphs and find what are called intrusions, identify them by eye, and then I'm making a neural net to recognize them. That's kind of where we're going with this. It doesn't matter for what I'm saying here now. Okay, so the next thing is variable. Okay, and we're in R, and that means to assign something. So I'm assigning to a variable called setup the following string. If you're familiar with SQL, you can see what I'm doing. I'm creating a table called floats, like I said I was going to do, and one called tags, and then the joining table, or it's probably a better word for it, called floats tags. Okay, and each one has an ID. I'm calling them ID underline float, ID, and you can see what I'm doing now. I guess that probably should say floats tags, but I'm not going to edit it in real time. These are integers, and this is a primary key. So it means you don't have to set it. It will set it for you. It'll be 1, 2, 3, like that. And let's see. So then, and I'm also storing the file. This is for my own purpose. You don't probably need it for this, but storing the file. The ID is a text string. It's not just a number. It's usually a letter followed by numbers, but. And then there's a cycle, which is saved as a text string. It should be a number, but sometimes there's letters associated with them too. Tags are simpler. We have the numerical value and we have the text. So just going back up, the numerical values be 1, 2, 3, 100, and 101, etc. Right, so here we go. I do a system call in which I remove I'm going to call the database argo.db. So I have a system call in which I remove that. And I have a little message saying I did it, removed it. About 20% of the lines of code that are in here, maybe 5%, are just debugging lines. After that, what I'm going to do is I'm running that setup and piping it in. I'm in a Unix system. I'm in macOS. I'm piping it into SQLite 3. That creates the database there. That's what the message says. Okay, you would do that only once. Okay, now what I do is I connect. So from line 41 down, this is how code would work. I would embed this sort of thing in my GUI-based tool for analyzing data. So I open it. This thing says how to open it. I'm not going to go into details of how to use SQL, or how to use R, or how to use SQL in R. What I'm doing in this block is I'm dumping all those tags into the database. Insert into tags. The key, that's a number, the text, and there's the number, and there's the text. So that's what this is doing. You have to do a DB clear result after every send query. I think that's just because you could have multiple processes accessing the database at one time, and you want to say, hey, everybody, you can write into it now. I'm done writing into it. Okay, so that's what that does. Now what I'm going to do is I'm going to show the kind of R code that you would use to set up some floats. And I'll just do 2 examples here. These are kind of relative local files for some Argo floats. They're in netcdf format. That's why it's an NC. And the way these things work is, actually, there. I've highlighted that thing is the ID. R means real time. This sequence number. And this is cycle 001. Okay, so those are 2 floats. This is just for playing around. Now what I'm going to do is I'm just going to run through them. This is doing a substitution, and it's finding it's grabbing this. That's what it's doing basically. If you're familiar with grep, etc., you'll see how that works. And if not, you should really learn that. So the first one grabs the ID, the R thing. The second one grabs the cycle, the 001, 002. Then I have a SQL command to insert that into the floats database. I send the query, I clear the result, and I spit out a thing because debugging is my life. Okay, and so now we've made that database, and now what we'll do is we'll have a look at, yeah, now what we'll do is I'll insert something. We've got the tags database made and the floats database made. I'm going to insert some of those connection into the connection database. So I'm going to imagine that I wanted to make the second float cycle. I'm calling it a float cycle here. Probably should have been saying that all along, but anyway, I'm going to imagine that it has a bad location. So the bad location is a key of 2. So we'll go back to here. Yeah, good. I'm going to say that it's a bad location. So the first thing I've got to do is I've got to look up the, since I've just made it, I know the ID, I know that sequence number 1, but imagine I didn't know that. So what I'm doing here is I'm finding the sequence number, the ID, the key number, where we have a particular Argo ID and a particular Argo cycle. That's what I'm doing there. I send that, and in fact, I know that that number should be 2 because I know I'm grabbing the second. Notice the 2 here. I know I'm grabbing the second, so I have a little sort of sanity check that's correct. You would never have that in your actual code. And now I have to find the tag, and I'm looking for the tag, which is bad location. And yeah, so just blanking out there for a second. I print it out, I do the query, and I make sure it's 2 because it should be 2. Because that is number 2. So that's good. And now that I know the ID thing, the ID for the float and the ID for the tag, I insert that into the database, send it, clear the result as usual, and disconnect. I should say that the way in which I've made this, the pressure level here has a default of 0, and I haven't specified a pressure. This is my scheme because I know for one of the data sets I'm looking at, some of the locations are completely wrong. It's because the float was under ice and it couldn't get a GPS lock. I can't use them for my particular purpose. You could use such data for other purposes. It's useless for what I need, just for the physics I need to be doing. So I don't even have to look at the data for that. Now, the actual code that you would have probably would involve looking at the data, and then that call that I made at the end, you would give a level. Okay, so that's the code. Now I'm going to share, I'm just going to, in a second here. I will. I don't know how to not share something. I could just, sorry. I hadn't loaded up. So now what I'm doing is I'm loading up an application that lets me look in a graphical way at the database. So that's what I've done. And this thing is called DB Browser for SQLite. You can just get it from wherever. Okay, so we can see the tables here. I'll just open up. I don't know how to make the font bigger. Don't know how to make the font bigger. So this says tables. The first one is floats. I've expanded it. And as expected, I have this auto incremented thing, the ID float. And anyway, these are as expected. Now let's have a look at the old data. So I can scroll here and I can get different ones. So the floats. So I created this, and this is the ID number, which is extracted correctly in the cycle. Anyway, they're called, that's floats 1 and 2, the ID number here. I know this is confusing. This is the ID for the database. The capital ID is the ID for the float. We'll check the tags. And you'll see that there, and again, this is auto-generated, and this is the numerical scheme that we're using, unassessed, bad location, etc. And there should just be one entry here. There is one entry. So this is just the auto-created index, the row. It's a row. It's just a row in the database. For float with ID number 2, the second row of the float table, and the second row of the ID table, and the level 0. Right. So what this code has done then is it's created, what I've just shown you how to do is how to do this, how to do this, how to do this, how to create them, and also how to insert in them. It's about what I wanted to show you. So again, I started by saying it's for Argo floats, and my code that as written says Argo floats. It really could be for any kind of level-based data. I guess it could be extended for time series based, but you don't normally do QC on that. We do quality control on CTDs and Argo floats a lot. And so, as I say, you could use this for quality control or analysis, which is great, has to be done. And it could also be done for my purpose, really, my real purpose is identifying things in the water column and tagging where they are for future analysis. Another example that could be pretty common, my purpose is sort of arcane. It has to do with a lateral mixing in the ocean caused by something called interleaving. It's a little bit arcane, but another thing that's pretty common is to find mixed layer depth. Biologists are super keen on that, on what is the mixed layer depth. And again, you could have, the purpose could be that you would have a technician just running through profiles. Honestly, to plot a profile takes about 1 to 3 seconds. To visually identify the depth of the mixed layer, maybe 1 to 5 seconds for someone who's trained to do it. Pretty difficult to do it automatically, algorithmically. I've talked a little bit about that in my book on oceanographic analysis with R, which you could Google for if you were keen for Googling for books. Okay, so that was it. I have been Dan Kelly. I work at Dalhousie in lovely Nova Scotia. And I bid you adieu.